So this is going to be a long, kind of drawn out YouTube video on where we're at right now in doing machine learning with Unreal using the Python plugin. What's on the screen right now is the last video I did. I suggest you take a look at that and see what's going on with it. But basically where we're at is we can now send images to this server process and using ZeroMQ and threads. And on the last video, we're basically just writing the image to disk. So now we're going to get a little bit into some machine learning, and we need to potentially make some decisions on what technology we want to use to take these images that are sent from this camera on this character that's randomly moving around a 3D Unreal environment and do object detection. So right now we are not trying to attempt to do any object detection using TensorFlow inside of Unreal. Even though there is an Unreal plugin that can do that for TensorFlow, what we want to do is train our models offline, and this is one of the ways we can do it. So I'm using an old example, Adrian. Let's see. Sorry about that. Yeah, Adrian Rosen, Image Search. I apologize, but I want to put this up on here because one of the examples we're going to be using is his code his implementation of the object detection. And so here's the link to that. That's kind of important. So if you subscribe to his stuff and pull down his examples, this is one of them. And I've used this in the past. I've used it for Halloween projects. It works great, and it's real fast. But it uses an older set of model machine learning technology, which is CAFE. So a little bit on models, machine learning models. Obviously, there's neural networks, but they're really convolutional neural networks. And you have certain models that can detect, binary classification, hot dog, not a hot dog, bird, not a bird, cat, dog, those types of things. You also have other models like this SSD model, single shot detection, which will not only detect one object, but it will detect multiple objects, and it will provide a bounding box and a probability percentage as well. So this particular solution uses Python OpenCV. I'm using 3.4. And when you do that, it gives you the ability to load in, you can load in CAFE models. These are the actual weights of the model that gets loaded into the structure of the machine learning model. So you'll have to bear with me there. A plain Jane machine learning model if you construct it, is empty, or the weights, the weights and biases, if you follow machine learning, they're random. So what you do is you train them and then you save your model, because you don't want to have to train it every single time. I say you save your model. What I mean is you save the weights and biases inside of your model to a file. And for this cafe example, they have, I think that's the protobuf, which might be the structure. I'm not going into cafe because we're not going to use that. But this particular MobileNet SSD can do object detection on these class of things. And that's fixed. We can't change that unless we retrain the model. And later on in this video, we're not going to go into retraining the model, but we're going to go into using a different technology, Keras Tensorflow, to get these same results, and then that will enable us to potentially retrain our model, so when it's detecting things, they're the things that we want it to detect. Might be a soccer ball or something like that, which I don't think is in here. So this is the OpenCV version of it, and I'm not going to really, you can look at this code, you can find it online, you can find the weights online, and then you're done and you can have fun. So let's run this to see what's going on. And loads it up, and you can see how fast that was. And it had to load the model, and it had to do inference. This is what inference is. It runs through, and you see these wonderful little boxes around all the things. We need that because what we're going to do is, when that picture from this Unreal object character gets sent over to the server, we're going to do object detection, only look for people, and then we are going to send commands back to this Unreal character and say, okay, this is, you just showed me a person in this box, and we're going to have to do some world coordinate translations. Say, okay, go in this direction, go towards this person, or go towards this car, or go towards this dog. So that's one. In a future video, I'm going to wire up the, I'm going to rip the code. Let's get out of this. I'm going to rip the code out of here, right? Put it in a module. And we are going to call it from the server right here. So right in here, we're going to take that image, and instead of writing it to disk, we are going to send it to a function like this right in here. So that's one thing we can do immediately without having to train any machine learning models right off the bat. That's one way. But then later on, we might be, hey, I want this Unreal character to recognize a soccer ball or a gold nugget or a something else. Well, this code, this is fixed. This is all it knows how to handle. So once we get the server sending back the coordinates using the OpenCV version, then we're going to do something a little bit more advanced. And the more advanced is going to be the same thing. We're going to use the MobileNet SSD model architecture, but we are going to retrain it to recognize the objects we're interested in. And then we can run this model remotely via the server. and all things are wonderful. Now, I may have said this, yeah, I think I did. There is a TensorFlow plugin for Unreal, and Keras models cannot be loaded into. We're going to use Keras and TensorFlow. Keras is the Visual Basic of machine learning. TensorFlow is the C++ version. So you really have to know what you're doing in TensorFlow, but you can implement this same model. But the point is that the TensorFlow plugin in Unreal doesn't understand Keras models, and we can do a conversion from Keras to TensorFlow, or we could just re-implement what I'm about to show you in raw TensorFlow, and this is a mouthful. Okay, so the next thing we're going to be talking about is okay, we know we want MobileNet SSD because it returns boxes, bounding boxes and percentages around the things that the model can recognize. But we might want to retrain it. We're not going to use Cafe. We're going to use Keras and TensorFlow. So what we do offline, we don't train models inside of Unreal. We run the models inside of Unreal. We do inference inside of Unreal. Even though you could technically do it in Unreal, we're not going to do that. We're going to use another tool of the trade, and it's called a Jupyter Notebook. And a Jupyter Notebook is basically a web page that can run Python code, and I'm going to show you how that's going to work here. I went online, I found a Keras MobileNet SSD implementation, and it came with all this source. It didn't come with the actual model weights. I'm sorry, not the right one. Weights. Remember, we got to load in our weights into our model, or we're going to have to retrain the model, which takes days. So the better thing is to load in our weights. And you notice this is a different file format. This is something that Keras understands. So we have a little batch file that says run the Jupyter Notebook. It comes up, and this is what a Jupyter Notebook looks like if you don't know that already. So not going to go into a lot of details of Jupyter Notebooks. They're all over the place, but if you're going to get into machine learning, this is probably where you're going to live for a little bit. So the one advantage we have with this fine gentleman's project is he also trains. So these are the actual notebooks themselves, and he has a trainer, but we're not going to go into that right now. So we are just going to do inference. This is the GitHub for the particular person's implementation, and you'll notice it's a little bit different. We are using Keras something I'll have to write down. We're using the older version of Keras. We're using the older GPU version of TensorFlow. I've got a GTX 1080 Ti, and I'll write a lot of this down if people want to get this far. And it has the NVIDIA drivers for that particular version of GPU TensorFlow. So, as we can see, he has a class in here called MobileNet, that's an abstraction from this SSD. And what we're going to do here, we can actually run this, what they call cell. We do Shift Enter, and it's running right there. And we can actually go in and we can see it communicating. And there's my graphics card. It's got 11 gigs of GPU memory. That's kind of what you're going to need if you potentially want to retrain these models. Or you can use Collab and try to run this stuff up there in Google's cloud. That's another video. So we have, it says it ran it. It kind of complained a little bit, and that's okay. So now, lo and behold, we have a Python array of the classes, the labels of the classes, just like we had in the other example. And in the Jupyter Notebooks, you have to run each cell one by one. So we do Shift Enter. It just ran that code. Now what we're going to do is instantiate the SSD single shot detector class, and just like in the other cafe example, the model has to load the weights. Now the gentleman has the weights up on the drive, Google Drive or wherever it is, and you have to pull it down, and you have to obviously rename these. Just give it a name that the Python model knows how to load. Okay, so we hit Shift Enter, and first glance you'll notice, hey, this takes a little while. Now, what we'll do when we have this in the test phase is we'll preload this model, and the server won't take any images, obviously, until the model is loaded. The next thing we're going to do is we're going to load in a image, and we have to do a little bit of conversion on it to get it to fit into our model. And it says it wants image.io.imread instead, but these machine learning projects that are online, it's a continuous fight with trying to keep the software stack all lined up to where these examples will work. So it doesn't really even matter if you get somebody's source code. You still have to know how to get the software stack right and all the pieces put together. And eventually it gets old and they go on to the newer version, and then you're like, you have to start all over again, which is a big pain. I don't know why he's doing this prediction here. He does it later on, but I put in let's do this. We're going to cut this cell out. We're going to click on this cell, and we're going to say plus. Now we have a new cell, and the cell can either be code or it could be comments. And you can do that by the cell type. And this cell type is going to be code by default. So let's go print preds. So it did some predictions. So now we get arrays of arrays of arrays of numbers. And we're like, okay, what in the hell do we do with that? And that's where these box utilities come in. And this is a lot of utility code that you don't get with Keras and you don't get with TensorFlow. And that's why these projects are important to find, because they go through all these details. So the box util is going to do what we think it's going to do, which is it's going to put boxes around, it's going to restructure the data. So he goes in and he does this again. It's the same prediction, and he does the box util detection preds again, but he's using wall time to just see how fast it is. And it's 37 milliseconds. And if you run this a couple of times, it'll start going faster and faster. Now, let's make sure this code runs. Okay, great. You notice something didn't happen down here. And I don't quite, it just did this to me. And I stopped the video, and now it's doing it to me again. So I'm going to do it again. Reload the thing. I don't know why it's in some jacked up state. We're going to just rerun these cells, but then what I'm going to do is this one down here. Glorious. Okay, well, it did it to me again, which is it basically isn't drawing the boxes around the items. Bear with me. Now you notice it says 27 milliseconds, so it went faster. Yay! I don't know what happened. Maybe these prints freaked out the results. So let me get that out of there so next time I don't do this. Because I didn't run those cells that time. Okay, and then this code has to go in and it has to peel out these arrays of values and match it up to the labels and then randomly draw these items here and the plots, yada yada yada. And as you can see with the same image, it basically worked. So, you know, a 1 on a person means it's 100% that that's a person, 100% that's a horse. And we need these boxes. And maybe I said this before in the video. Because we are going to translate that back. And we are going to send those coordinates back to this character right here. And again, this character is going to start heading in that particular direction. So we went through this whole thing here because in the next couple of videos, as people are following me and want to follow me, they can go back to these videos and reference, well, why are we using Keras instead of OpenCV, things like that. It's simply because we're going to want to come back in and we're going to want to retrain that same model technology and get the model to recognize the things that we want it to recognize. And I just opened up this tray. As you can see here, this is creating another single shot detector, but it's using what they call the VGG16 model architecture. So there's a whole, if you Google VGG16, if you Google MobileNet, you will find out about all of these model architectures that you can use for different purposes. Then you have to decide, do you have enough horsepower to retrain some of these things on these data sets? ImageNet is one of the data sets. Those are the actual, that's the data that they use to feed into the models when they train them. And some of these models, it could take days to train to get the same accuracy. And we're probably not going to, we're not going to retrain from scratch. What we can do, and I know this is at the end of the video, we can do something called transfer learning. So we can actually load these models up and we can load the weights, but we can do something called don't load the last layer of the model. These models are in layers, and the last layer is usually the prediction layer. And that's where these classes come into effect. And you can load a model and you can pop what they call pop the head off the top of it, and then you can start retraining that model from that point. And you can add your layer, which is I want you to just detect a basketball, and it will take all those previous weights that are in there for all those other objects that it was trained on, and then it will use those for the new object you're trying to detect. Now what happens is you lose all of this ability in that model. Unless you want to go get all of this training data that was used to originally train this model and then add a class, which is a bowling ball or a soccer ball or a basketball or whatever. And I'm not going to probably go into that in very much detail for the next couple of videos. So this was a massive rambletron of and hand waving of what the next couple of videos are going to be about. But a shout out to Adrian Rosenbrock. I've learned a huge amount from this fellow. I still subscribe to his stuff. I would strongly recommend if you're going to be getting into this. He does a lot of the image processing work, but now what he's doing is he's getting into the machine learning world, and it's helpful, big time helpful. So massive rambletron. If you got this far, you're awesome. The goal of this project is a client server machine learning, have the character move around, take pictures, do remote inference, not inside of Unreal. We're going to do it inside of our Python process. Then the Python process is going to send commands back to Unreal to this character to tell it to do what's next. But once we get this working, then we have the framework to create road following algorithms. Because now what we've got is the ability to train our own models on our own data sets that can eventually run once we get them converted to TensorFlow and have that code run all inside of Unreal. So that was a huge video that I just did straight through. Now I'm exhausted. Hope this was useful. If you have any questions, just post them down below. I don't make any money off of YouTube. I'm just trying to, this is more of a resume than anything. But I am really excited about Unreal and Python and machine learning, all in one, as you can tell. Anyway, that's it for me. I'm exhausted. Thanks for watching this long. You're great. Talk to you shortly.